Hello, everyone. In previous lessons, we have studied the fundamental principles of industrial robots, programming and debugging, signal configuration, and communication settings. Today, we will use a typical application of an industrial robot handling workstation as a case study to learn how to apply the knowledge we've acquired to practical applications. This lesson mainly covers the following content. Firstly, we will study the hardware components and functions of the handling workstation. The structure of a typical handling workstation is not complex. As shown in the figure, a typical handling workstation mainly consists of the robot body, material conveyor belt, material storage platform, gripper mounted on the robot's 6th axis, pneumatic control devices and control circuits, and material detection sensors. Among them, the material detection sensor is primarily used for detecting whether there is material on the conveyor belt and feeds back the detection signal to the robot. A specialized gripping tool is installed on the robot's 6th axis to assist the robot in grabbing and storing materials. The pneumatic control circuit controls the suction cups on the robot's tool, as well as the positioning fixtures and clamps for materials on the conveyor belt. Next, we will learn about the control requirements of the handling workstation. When the conveyor belt transports materials to a designated position, the sensor detects that materials have arrived. The robot I/O drives the positioning fixtures on the side of the conveyor belt to action, positioning the materials properly. 1 second later, the robot moves to the side of the conveyor belt to grab the materials. When the digital pressure gauge reaches the set value, the robot leaves the grabbing position and places the materials on the storage platform. Once 3 materials are stacked on the storage platform, the current handling task is completed, as shown in the simulation video. First, when the first workpiece arrives and is detected, the robot goes to the grabbing position to pick it up and then places it. Then the second workpiece arrives and is stacked on top of the first one. The third workpiece is grabbed and stacked on top of the previous one, completing the task. Next, we need to assign signals to the handling workstation, as shown in the assignment table. After completing the signal assignment, the next step is to draw the electrical schematic diagram. From the assignment table, we see that our signals are assigned to both the robot body EE interface I/O signals and the signals on the extended digital interface CRMA15 board. Therefore, we need to draw the electrical schematic diagrams for both the EE interface and CRMA15 board according to the signal assignment, as shown in the figure. It's important to note the signal assignment on the CRMA15 board. In previous lessons, we learned that the DI signal input on this board is active high, so when selecting photoelectric sensors, it is essential to choose PNP-type photoelectric sensors. At the same time, from the schematic diagram, we can see that we have assigned the output signal of the conveyor belt photoelectric sensor to DI120 on the CRMA15 board, corresponding to the 25th pin signal channel of the board. Therefore, we also need to define the input channel of the 25th pin as DI120 in the teach pendant for it to take effect. Similarly, DO120 corresponds to the 40th pin signal channel of the board card, which needs to be defined as DO120. Next, let's look at the pneumatic schematic diagram. The vacuum generator is connected to a 2-position 3-way valve, and the conveyor belt cylinder is connected to a 2-position 5-way valve. Subsequently, we need to connect the pneumatic circuit according to the pneumatic schematic diagram. In this lesson, we introduced the composition and working principle of the handling workstation, assigned related signals, and designed the electrical and pneumatic schematic diagrams based on the assigned signals, laying the foundation for further learning. Lastly, please complete the following exercises. See you in the next lesson.